in the sense of this thing here, we did this last time. Hopefully this time around, the second time around, you can see, recognize when is a mutually exclusive event, when is a not a mutually exclusive event. And again, if you recognize those, if you recognize that the mutually exclusive and not mutually exclusive, then again, all you do is, if it's not mutually exclusive, you subtract what they have in common. If they are mutually exclusive, they have nothing in common, so you don't have to subtract anything because they have nothing in common to subtract, okay? So question with number 1 through number 7. All right, if you don't have a question, let's take a look at the conditional probability. Why is a conditional probability, or why do I know that? Well, besides I typing this up, if you read this thing here, you know, for you guys, if you read this thing here, you see the word given, right? You read, no, that's the one thing you ask yourself is, if I read a problem, how do I know is it a mutually exclusive? How do I know if it's a conditional probability, or how do I know next time the independent, right? Again, so if you look at this thing here, this 3 problem, number 8, 9, and 10, if you look at this 3 problem, you see the word given, right? And that should trigger, or that should let you know that, oh, the word given tell me that is some condition have to occur first. There are some condition that I need to take out. I have to have that condition. And what is the condition that happened first? Well, the condition that happened first is the people all follow the word given. So looking at this thing here, who am I extracting out first, right? That's what you need to ask yourself. You only select one person. One person is select at random. Find the probability of that person is in the age group of 42 to 47, given that that person is a female, which is, everybody see that this is what we have to take out is, we have to first, what is the given part, which is, again, this is what I need to extract out. I don't care about a male, right? Let's say in this classroom, I have male one side, female one side. I say, okay, all male, I don't worry about you guys. I just take out the 18 female. That's the first condition. Now, out of this 18 female, do you agree that out of this 18 female, how many of them are in the age group of 42 to 47, which is, do you agree that there are one of them? Right? So if you look at this thing here, this is what you need to do is, we know that this is what they ask us, is they ask us the probability of 42 to 47 given that person is a female, which is now, like I mentioned, we need to extract out all the female, the condition that have to met. We are no longer deal with the 30 people. We deal just the 19, which is, again, why 19? Because that is the female. That's my female category. I have 19 of them. Now, out of that 19, how many of them fit the description that is they are in the group, or in this case, that person, one person in the age group of 42 to 47, which is 1 over 19, which is, if you divide this thing here, you have 0.053. Okay, so again, what is the difference between this problem versus the other one? This problem, some condition have to met. You have to extract something out. And in this case, you extract the female, which is 19 of them. Everybody see what is the keyword and how do we attack that keyword? Question here with in terms of number 8. And number 9, let me ask you guys, number 9, what am I extracting out first? What is the condition that I need to take out? What group that I need to take out first? Anyone? Don't go at once now. So again, you have 2 items, right? You have a male and you have the age group of 24 to 29. Those are your 2 conditions. Now you ask yourself, well, what is the condition that I need to extract out first? What is the condition that have to happen first? Which is, reminder, anything follow the word given, right? Meaning, looking at this thing here, everybody see that I need to extract out the age group of 24 to 29 first. How many people is in the age group of 24 to 29, which is in this case, I have 5 of them. Everybody agree that I have 5 in the age group of that. Now, out of that 5, I'm just focusing on that 5 because that is the condition that I need to focus in, or that's the condition I need to look at. Just out of that 5, how many of them are female, which is in this case, not female, how many of them are male, which is, do you agree that we have 2? Which is in this case, which is again, everybody see that we have 2 over 5, which is 2 over 5, the probability of that will give me 0.4, okay? So again, that's what we have here. This is not mutually exclusive or not exclusive, not a mutually exclusive event. This is a conditional probability. Okay. So again, looking at this thing here, question again. Everybody recognize that where is your? The first thing is you have to ask yourself, where is your new total? Where is your denominator? So again, as you can see up here, the female is your denominator. Excuse me. Down here, the 24 to 29 is your denominator, which is, again, we're looking at this item, which is the 5, and this item is the 19 for number 8, okay? So if you look at number 10, again, what follow the word given? What is given to us here, or what condition that we need to worry about first, which is, again, hopefully you say, well, given the person is a male, which is, do you agree that male is the first condition that I need to take? That's too light. So again, looking at this thing here, everybody see that this is what we have, is we need to take out all the male student, right? So all the male student, which is in this case, I have 11 of them. Out of that 11 male students, how many of them are in between the age group of 36 to 41, which is 36 and 41, I have 1 of them, right? So looking at this thing here, as you can see, this is what I have, which is probability of 36 to 41, given that that person is a male, right? Find the probability of a person in the age group of 36 to 41, given that person is a male, which is, this is what I have, which is, again, I have 1 over 11, which is 0.091, okay? So again, question with this thing here, question with this conditional probability. Now, let me go straight to the next one, which is, again, let's take a look at this thing here. Let me erase all this item. If you look at this thing here, which is, again, first of all, I want you guys to see or read this item with me, or in terms of this item, we are selecting 2 people, okay? As you can see, we haven't done this, and I haven't shown you the definition. But let's attack the problem before we look at the definition, see if the definition makes sense later on. So as we look at this thing here, first of all, because we select 2 people, because we select multiple times, and now that's the trigger that because we select multiple times, I have to, or we have to multiply, okay? So when you see this and, remember last time I told you guys that the other word, the other and, if we select one person, the word and is and also, right? We're looking for something that this and also that. But now this word and right here, this is what they ask you is, if we select 2 people at random, find the probability of you select a male and then you go back and select a female. Okay, meaning we select multiple times. We go in the first time, we pick out one person, and then we go back the second time, we pick out another person. Everybody see this and versus the other one, I select one person. What's the probability of female and in the age group, which is and also. Okay, so let's take a look at this thing here. After you recognize that we do or we pick multiple people, And this is tell us that we go in the first time and then go back the second time. Now you ask yourself, is the 2 time that you go pick one and then you go back pick a next one, does the 2 time, are they independent or are they dependent? So what does it mean independent? Independent meaning basically if they are independent, meaning the probability, no matter how many times you doing it, the probability does not change. Meaning the second probability doesn't change by the first one. Meaning, for instance, if I told you that I have a coin in one hand, like if I have a quarter and I flip this quarter, right? And I have the dice on the other hand. And if I flip the quarter first and then I roll the dice, everybody see that I'm doing 2 events. I flip the quarter and I roll the dice. Does the 2 event, is or all the 2 events, or they affect each other? Meaning, if I flip the coin first, does it affect the probability of me rolling the dice? Does it affect that the dice will come out differently because I flip the coin? Hopefully you say no, right? Because the coin and the dice, unless they hit each other, right? Just assume that they don't hit each other. I flip the coin and then I roll the dice. Doesn't matter how many times I do it. Every time I flip the coin, it's 1/2. Every time I roll the dice, the number come out is 1/6, right? So again, as you can see, the 2 event does not change at all. No matter how many times you do it, the 2 probability is still 1/2 and 1/6, regardless of what you try to looking for, right? So if they do not change, we say that they are independent. So looking at this thing here, let's take a look at the story that they built for you guys, right? We go in the first time, I want to select a male. I go back the second time, I want to select a female without replacement. Meaning, again, without replacement, meaning once I select that person is gone. I do not put that person back, right? So the second time I go in, do you see that there are some changes? There are something changing, right? So looking at this thing here, this is all they tell you is if you determine that they are, let me ask you guys, what is the probability of me select a male? Looking at this thing here, what is the probability of me select a male? So this is what they tell you is, do you agree that I'm going the first time? The probability of me select a male is I have 11 male out of the total of 30. Right? What is the probability of a male? If I go in and select one person, what is the probability of a male? I have 11 male out of 30. And ladies and gentlemen, we assume we got a male. We assume that the male is gone. We pick him out. Now I go back the second time. I don't replace him back. Do you agree that there are something that changing? Meaning now I go back the second time, I no longer have 30 people. Why I don't have 30 people? Because the one male that I pick, I say, get out of the classroom for me. Now I go the second time and I pick, right? Because the probability is changing or because the denominator is changing, everybody see this. Originally, we have 30 people. I select one person, that person get out of the classroom. I no longer have 30 people in the classroom, I only have 29. So because the denominator changing, we say that this is dependent. And again, all we're doing is we just multiply, which is the top times the top, which is 11 times 19, divide by the bottom times bottom, which is 30 times 28, which give me 0.24. Meaning the probability of me go in, pick out one person at a time without replacing, and the probability of me get a male first and the female second is 0.24, 24%. Okay. And again, let me do C. I mean, not C, let me do number 2, and then I will take your question, and hopefully after you see number 2 is clear out in the air a little bit, which is looking at this thing here. This is what they ask you is find the probability of select a male and then go back and select a person in the age group of 30 to 35 with replacement. What does it mean with replacement? Meaning I pick him out and I put him or her, well, in this case, him back, right? Which is because I put him back, which is, do you agree that the probability of male is 11 over 30? And because I put him back, I got the male, I got the first male here. I record his name, I put him back, and because I put him back, everybody see I have the original 30 people back because I replace him back, right? Up here, I don't replace him. That's why I no longer have 30, but I have only 29. This one here, because I replace him back, I have 30 greater than 29. And again, how many of them in the age group of 30 to 35, which is 7/30, which is, again, this is what we have, which is top, bottom, bottom, which is we have 0.086. Again, number 2, we say that they are independent. Because if you replace them back, the probability is the same every time you select them. No matter how many times you do it, the probability is, the denominator, the total is still 30. Okay, so again, this is your dependent versus independent item, or dependent versus not dependent, which is not dependent. Sometimes you hear me say that they are not independent. Sometimes you hear me say that dependent. Okay, but again, first of all, question with number 1 or number 2. Let's do number 3 and number 4, which is, again, if you take a look at number 3, looking at this thing here, we asked again, what is to find the property of select both female with replacement? Meaning, again, I want to go in and select one person. I want to select a female. I write her name down. I record it. I go back and I replace her and I pick out again. Yes, I might have the same girl. I might have the same person twice, but I don't care. We just want to know what is the probability of me going there, pick out one person, is a female, and then go back and pick out another person, and that person is also a female, right? So looking at this thing here, because we replace her back, because we put her back, everybody see that this is what we have is, again, the probability of a female and then another female is, find the first probability of female, which is 19/30. And again, what is the probability of the second female, which is the second female is, again, 19/30, because I replace her back. Again, because I replace her back, the probability is the same, which is they are independent, right? No matter how many times, if you want 5 female, if you keep on replacing back, then it's gonna be 19/30, 19/30, 19/30, 19/30, 19/30. Right? Because if you keep on replacing back, the probability will not change. Okay, which is given this thing here, 19 times 19, 161. I mean 361. Divide by 30 times 30 will give me 900, and then you divide them to give you 0.40 of roughly 40.1%. And if you look at that, and if you look at number 4, you see that, oh, they are without replacement, right? Find the probability of select both people. And this 2 people is between the age of 42 to 47 without replacement. So again, basically we're looking for the person, 2 of them, 2 people in the age group of 42 to 47 and 42 to 47, which is, in this case, everybody see that, again, the first one we have is how many 42 to 47, which is I have 3 of them, over 30. I got them, ladies and gentlemen. I know it's very small, it's only 10%, but we assume that we got that person. Now, we don't replace them, we go back the second time. Everybody see that we go back the second time. We go back the second time. I no longer have 3 original because I took out one of them, right? I took out one of them, doesn't matter if the male or the female, I took out one of them in this age group, which is now I only have 2 left. And I no longer have an original 30, I have 29 left. And as you can see, the second probability changes, right? The second probability affected by the first one. And because it's affected by the first one, we say that they are not independent, and they are not independent. But again, the arithmetic is very easy in the sense that 3 times 2 is 6, and 30 times 29 will give you the denominator, and then you divide them to give you 0.007. Question with this one here, question with this 4 problem here. Now let's go back. Let's go back to, I guess this should be let's go back to this thing here. So if you don't have question, let's take a look at this item here. So let's continue with this item. Let's go back to our definition. I mentioned about the dependent. I mentioned about dependent, but let's skip this one for now. We'll go back. I mentioned about the dependent and the independent without telling you the definition itself, right? So this is your general multiplication rule. Your general multiplication rule is this, which is again, probability of A and B, which is again, multiplication rule is when you do multiple times, right? So the probability of A multiplied to probability of B given A is already taken out. Meaning again, this is basically all they tell you is if the two events are independent, meaning again, one curve does not affect the probability of the second item. If they are not independent, we say that they are dependent, which is again. So this is what they tell you, that if you know, if you recognize, if you identify that the two events are independent, then all you need to do is take the first event, multiply to the probability of the second event. And that's it. And that's what we did last time, right? We find the probability of the female and probability of the male, which is if we keep on replacing them back, all we did was we multiplied them, okay? So again, the difference of this thing here is a conditional probability. And you say, wait, this is conditional probability. Yes, because something happened that affect the outcome. That's why, again, we have a conditional probability here, which is we have one less. Because we pick out, we have one less, okay? So let's take a look at this problem here, and I guess this should be a good stopping point. We will go over the other problem that I have that I skipped. So let's take a look at this problem here, which is, again, a storage of 10 computers. Contain 3 of them are defective, right? So again, looking at this thing here, this is the story that they built up for you guys, right? In the storage room, there are 10 computers. And 3 of the computer is defective, meaning they are broken. We don't know which 3, right? So now they say 2 computers are drawn at random and test. So again, everybody see that first. How many computers are we drawing? How many computers are we taking out? We're taking out 2 computers, one at a time, right? So again, because we take out multiple items, hopefully you guys remember that because we take out multiple items, we need to multiply. But let's take a look at the rest of the information they give us, which is again, let A be the event that the first computer draw is defective. So again, probability of A is basically, we take out one computer and that computer is broken, is defective, right? And let B be an event that the second computer is drawn and is defective. Meaning again, part B, meaning we go back and we select the second computer and that second computer is also broken or defective, right? So looking at this thing here, which is again, looking at this thing here, looking at this item that we have, which is again, what is the probability of A? Well, probability of A, do you agree that if you go in the first time and you select one computer, the probability of A is again, how many computers are defective, which is we have 3 out of 10. So if I go in to my storage and pick out one computer and test, the probability of that computer is broken is 3 over 10, right? The chances of me get that computer and that computer is broke is 30% or 0.3, right? And now they ask you, find the probability. If you read this thing here, this is what they ask you is, find the probability of you select a second computer and it's defective given that one of them is already taken out, right? given that one of the defected is taken out. So looking at this thing here, as you can see, what do we have, which is again, when I go in the second time, do you agree that because I did not tell you that we replace it back, because when I go in the second time, I no longer have 3 defected computer. I only have 2 because one of them is taken out already, right? Port A, I took that computer out. And same thing go, no longer do I have 10 computer because now I only have 9 because one of them tested and I know it's broken. I put it outside. I did not put it back into my storage, right? So looking at this thing here, this is what I have is if I take 2 divided by 9, I have 0.22222, right? And now port C, they ask you what is the probability of the event A and then event B happen, right? Which is looking at this thing here, we know that because they are dependent, or basically because they ask us to do multiple times, probability of A and B, all I need to do is find the probability of A, multiply to the probability of B, given A is already taken out, which is again, in this case, I have 0.3 times 0.2222, which give me 0.066666666, which is 0.0667, okay? Is A or A and B independent? Hopefully you say no, because as you can see, the probability of B change it, right? The denominator in B are different. And because they are different, if the denominator in B is still 3/10, then they are independent. They have the same probability. But because in this case, the probability change it, the probability is not the same. And that's why they are not independent. And they are not independent, meaning they are dependent, okay? They depend on one another, okay? Question with this one here. Question with this item that we have. Well, ladies and gentlemen, if you don't have question, this is a good point to stop. We will go over the problem I skipped next time, and we will continue more with the problem, and hopefully tomorrow when you see something like this again, okay, I will, so you cannot download the file down. Okay, I will upload that file 4.1 with the rest, 4.1, 4.2, 4.3, and 4.4 today. I will upload to Canvas. If you don't have question, reminder, whoever came late, make sure that you type something in chat room. The other thing is make sure, ladies and gentlemen, whoever came late, make sure that to register for your midterm on Canvas, not on Canvas, sorry, on ProctorU. I will make an announcement. I will send an announcement on Canvas tonight and tell you the instruction, whoever came in late, tell you where to go, what you need to do, and what day that you can register or pick. And then I will post the video. I probably will post both video, the 9:30 meeting and the 12:30 meeting. I will label them so that you can similar. I mean the 9:30 is a little bit faster. I mean a little bit more material because we happen to miss one day, so that class go a little bit ahead of you guys, but it's not that much. We kind of catch up